Still loading.
Okay,
Okay, go ahead. Yep, you're good.
awesome. So the topic I will be going over in this presentation is um, Android URL, Android HTTP URL connection. As you can see here, I have a few websites open that will talk about some of the main things that I learned, as well as just looking into what URL connections are. So a class overview for this that I found was a URL connection for HTTP RFC 2616. Use to send and receive data over the web. Data may be of any type and length. This class may be used to send and receive streaming data whose length is not known in advance. Use this following class pattern. So pretty much I'm gonna just explain what I learned from this at this point. All this does HTTP URL connection as it's integrated into Android. What it does is send and receive connection to the World Wide Web. So it's pretty much how Android devices are able to communicate with the web. From just to put it simple, at least in my understanding. So the system, how it works, it obtains a new HTTP URL connection by calling a URL that open connection, which would be whatever that URL connection is. For example, HTTP colon forward slash www.android.com forward slash. So you're sending a request to an open connection and casting the result to the HTTP URL connection. So after the request is sent, the primary property of the request is a URI, which we'll get into in a little bit from now. So it's pretty much an object-oriented language. So it still use all your sending setter and getters. I think that's kind of the word they use for them. Came across it earlier when I was studying it, but I can't remember where it is right now. Anyways, but yeah, and they still have the try. So this try right here, I don't know if you guys can see that.
Yeah, I can see that. Yep.
Okay, so yeah, just like when we're programming in object-oriented languages, you can do your try and catch. In this snippet of a code, it show you like an input stream. So it started just as I was explaining, the URL, and then it pretty much define a URL equals new URL, and then it input that open source connection, that open connection, which would be a direct connection to the World Wide Web, which is in this case it's the android.com. And because it's HTTP based, you have to put it in directly when you're coding, because it's not like just going on Google and searching for something and it will just magically figure out what you're looking for. You have to be very specific with this. So then it done here, HTTP URL connection equal HTTP connection URL that open connection. So you're telling it that, okay, so what I'm hoping to achieve is for you to connect to the World Wide Web via the URL open connection. And then it says the try and catch system here. That's whenever I see the word try, I figure that it's try and catch. So it says try input stream in equal new buffered input stream URL connection that get input stream read stream in. So that's pretty much where you're getting out, and then the result you'll be getting is the URL connection that disconnect once you finally get all that you need to get done from that URL connection. HTTPS is usually just a secured form of the hypertext language. So it also involves response handling. So you need to figure out how to get your inputs and also input your exceptions. because most object-oriented languages require exceptions, because you have to try and see what works and what will fail, and have the system or the program know just how to handle those exceptions. And then here we have an example of posting content. So this says to upload data to the web server, configure the connection for output using set do output true. So you have to establish that once you want your application to send information out, you have to set it that the do option in it is going to be true. Because if it's not, you're not going to be able to get anything out of your program. For best performance, you should call either set fixed length streaming mode int, which simply means if you're gonna use anything in integer, you need to use, if it's gonna be streaming, you need to set it a fixed length, and you must make it int. So integers, in other words. When the body length is known in advance, are set chunked streaming mode int when it is not. Otherwise, HTTP URL connection will be forced to buffer the complete request body in memory before it transmit, wasting and possibly exhausting heap and increasing latency. So it's very important for us to be specific, as I said earlier, with what we're doing when we're using HTTP URL connection. Because if we don't do that, we're talking about the internet has database that whatever devices we're using cannot contain it, because it do not have that much memory. However, if we're not specific, it's gonna try to load all of that data and overloading your machine, and then you won't be able to get anything done. It's gonna end in a result of your program crashing and stuff like that. So here's a program here again. So they're showing you the out and stuff and in programs of it now. So it starts with the standard HTTP URL connection. URL connection equal HTTP URL connection, just like we had up top earlier. Then it says URL connection that set do output equal true. And we already talked about that being the case once you wanted to send information out from the device. URL connection is set chunked stream mode 0. So at this point, you're not going to be, you're already establishing that you wanted to send stuff out. And then you set chunk mode pretty much to 0. Then the output stream out equal new buffered output stream. URL connection that get output stream. Writing stream out, input stream in equal new buffered input stream. URL connection that get input stream. And I guess the rest is pretty much self-explanatory. Performance. So this is how it works. The input and output stream returned by this class are not buffered. Most callers should wrap the return stream with buffer input stream or buffer output stream. Callers that do only bulk read or write may omit buffering. When transmitting large amount of data to or from a server, use stream to limit how much data is in memory at once, unless you need the entire body to be in memory at once. Process it as a stream rather than storing the complete body as a single bit array or string. So that's kind of explains some of what I was talking about earlier. That we want to save our information. We don't want to save all of the information if it's not needed. It's just a waste of time and just lengthy waiting for buffering to take place. The HTTP has to go through an authentication process. It uses an authenticator to set the VM-wide authentication handler. Authenticators, and there's an example of this on here. Are you guys able to see that?
Yeah, I can see that. Yep.
Okay. Authenticators that set default, new authenticators, protected password authentication, get password authentication, return new password authentication, username, password, that to char array. So we can set stuff to authenticate if we, we don't want it, our websites or so forth to, whatever you're sending, it can be secure. You want to have a secure connection. So each person who uses it has to authenticate by using a username, password, and stuff like that. It goes into session with cookie, the methods, proxies. It goes into the actual network aspect of it, like IPv6 support. And then down here we have a summary of all the stuff that it will go through. But this other website that I went to that shows us tutorials and examples.
And those are the ones you put in the link or the chat, right?
Yes.
Okay, thanks. I appreciate that.
So they go again and said like create a URL instance. It's URL equal new URL. So this is like a more detailed version of it. And then they give you like open URL. So it's more spot on if you want it that way. So it give you like the step by step. So open URL number 2, open URL connection and cast it to the HTTP URL connection. So then you go down here, HTTP URL connection, HTTP con. I think that's abbreviated for connection. So here, then you have it in parentheses, HTTP URL connection, URL.open connection. So you're really accessing that open connection aspect right there. Then the next step is set request method. The request method can be get, post, delete, etc. Request method must be uppercase, otherwise below exception will be thrown. Java.net that protocol exception. Expected one of option get, head, post, put, delete, trace, patch, but was get. That kind of sounds like bad English, but it's actually the same. So HTTP connection or con that set request method. So this is pretty much how you tell the program that you're trying to get information. So it's like when you're doing setters and getters. So this is saying you need to retrieve information. And so in this instance, we use one of these keywords so we use get. So we can use, as I said, you could use any one of these options for the exception. Sorry, I almost lose you guys. So if request method is get, then use below code to open input stream and read server response data. Input stream equal HTTP con that get input stream. Input stream reader equal new input stream reader. And in parentheses, you put input stream again. Buffer reader. So it's just giving an example how you would define the get information for this. Then they say for post, you definitely want to do something similar to that as you do with get, because essentially it's the same thing. It's just using one of those keywords for a given situation. After you use HTTP URL connection, do not forget close related reader or writer and call URL HTTP URL connections. Disconnect method to close the connection or connection to release network resources. HTTP con.disconnect. So here is like a snippet of the example, what it would look like if you were per se to create that as a program. It show you the result of it. So it's showing you how the entire coding looks for it. So it says in this example, read server response process is occurred in a child thread. The child thread sends a message to activity main thread handler object to update the response data in a text view. This is because child thread cannot update UI, which is user interface control in activity directly. Otherwise, an error will happen or occur. Then show you like main activities, URL connection activities. I don't think I want to go through all of this. So you just basically import all the stuff that you need to use in your program. Then you can get into the child threads, so it can handle those kind of situation like as shown in that brief little video. There's this one word that I came across that I didn't understand, and it was async task.
Oh, async task, yeah.
Yeah, sync.
So that just means that it's not like other things can keep running while that's running. Yeah, that's what that means.
Yeah, I had to research it. Thanks for explaining.
I'm sorry.
No, you're good. That helps. You pretty much put it simple. So it's a really cool thing. I figured out that it's really helpful in our programs, and that's just like how you get stuff running in your background while like you open an app in your phone, and then it's making a connection to the URL while you're trying to use it. So let's say you have an app for a bank in your phone. You connect to it, and then you put in your password, and then you wait on it to be loading. The async is pretty much making all those connections take place. If I'm correct, that's what I understand from it. So that's pretty much where I was at, and then this is one of those from the video that we receive for this topic. How do you perform simple task using the URL directly from a URL when you're doing the URL connection? And then it shows us example. You need to import like a Java.net and Java.io. And then they give you a simple little example here. So for people like me to basically understand what's taking place, because I'm so new to programming that a lot of these things are foreign to me. But yeah, so without taking any more time, so these are some of the stuff that I learned as I went through the topics.
Yeah, that was perfect. Yeah, okay. Thanks, Randy. Christian, did you have any questions for him?
No, not at all. That was pretty good, man. Thanks.
Yeah, no, those are perfect. I think that's exactly what it sounds like he's looking for. So that's perfect. All right, I will go ahead and share my screen real fast. All right, so I'm going to cover just application controller really fast. So if you guys haven't, I didn't know this website existed, but it's this GitHub Yenrab doing more with Java. It is pretty much the books repository for examples of everything, of pretty much all the code base stuff. So it even has, it has the JSON stuff. It has, I was looking to see if it had the HTML. It has server connections and runnables, but I don't think so. Anyway, it has, some threading stuff. It has some handler stuff. It has JSON stuff, Hibernate. So anyway, awesome example. So I'm going to be using that as this, and I'll put this in the chat after the video. But so what is an application controller? I'm going to show you this overall chart here. So in order to separate responsibilities, and like Randy said, in Android, child threads can't interact with the UI. So we need some kind of way to do that. Okay, so in this example, a user puts in his name or his username, Bob, and puts in his password. And then he's putting that into the UI application. And all that the UI application, and this is just one class, is going to do is say it has a handle request class that says, hey, this guy wants to log in. That's a key. And then here's the data that he sent me. I don't know what to do with it, but here, boop, and he passes it over to the application controller. And that's where this app controller comes in. This controller now is sitting there waiting for these requests, and it's going to handle it based on what the information it was given. So the key is this first part right here, this login. It's going to use what's called a hash map. And all a hash map is, I'll switch over to the code really fast. A hash map it couldn't be anything. It has one thing, which is usually called a key, and then a second thing, which is the value of that key. So in this case, the string was login, and the object was the data being passed over, which is Bob and his password. Okay. It still doesn't know, this application controller still doesn't know what to do with it. It just is like it's like one of those phone operators with all the, the cables. It just is like, where do you want to go? Oh, okay, yeah, let me connect you. So it's going to use the hash map, which has all this. It has all the keys and then how to handle it. And so you can see here, it says, okay, what's my key? Get the login. Okay. Login is my key. Hey, Randy, do you mind muting your computer? Oh, thanks, man. So it's going to use the login, and it's going to look in the hash map and say, hey, hash map, what's the value for the key login? And it's going to go, oh, you need to use the login handler. And so it returns login handler back to the application controller. And the application controller goes, oh, okay, cool. Hey, login handler. And it spins up a new login handler. And it says, hey, handle this. Again, the application controller doesn't know what is going to happen. It just says, hey, I know that you're supposed to handle this, whatever I give you. And I'm going to give you Bob and this information right here. And then it passes it to the login handler. And the login handler goes, oh, I know exactly what to do with this. This person wants to log in. And so it grabs Bob, makes sure that Bob is an actual user. It grabs Bob passwords, and it's going to compare it to whatever was passed in. Usually, I mean, if this was a real kid, it would use a hash table or whatever. But yeah, and it's going to say, oh, it matches. And then it is actually going to carry on with what's being handled. We don't have to go into that much depth, but we do. He said the key thing we need to do is make sure to use this hash map. We need to pass it in a value, and it needs to return what is going to handle it. So in this example here, this is his controller. So here we're talking about this layer right here. Again, it's not handling the data. It just needs to know where to send the data to. So in this example, which is it's this application controller right here. He says, all right, I'm going to handle this request. I'm going to pass in some command, which in our case, in this example, was the login. And then here's the hash map and it's going to have, and this is going to be the command, which was login. And then the object is actually going to be the handler. And so it's going to come in here and say, all right, create a new handler and get this command right here, which was login. And then, hey, login controller, handle it. And it's going to then log you in. We don't have to use the login example. We can do whatever. In my example, I used a math function. So I passed in two numbers and I said, add these. And so my key was add. The command was add, and it's going to return a addition handler. And the handler then takes and I pass in the data into my addition handler, and it takes those two numbers, adds them, and prints them to the console, and that's it. So, and you can, but to extend the idea, you could have a command of subtract, right? And then you would need a whole nother different handler that would only handle subtractions. So it's really just kind of a really fancy way to get the data where it needs to go, and so that each class is handling it in the way it's supposed to handle it. Does that make sense? It's a really different concept. Like, I've actually never used this, and so it was really cool to see that. And then again, it really clicked when Randy was talking about Android, because I was like, oh yeah, if you just put in data here and then send it out off into a thread, say, hey, here's the data, that thread actually can't update the UI. So anyway, it's really cool, like how it all finally comes together. But again, I don't think we'll be getting into that depth on the basic level. But does that make sense? Do you guys have any questions on that?
No, that was actually pretty good, because now it makes sense. The part of the threading that I was looking into last week, Basically, this one just handles everything and distributes the information and sends it where it needs to go. Correct?
Yeah, exactly. That's what this. Yeah, and that's exactly. So it's using a hash map to just say, hey, where does this data go and who's going to handle it? And it's just this is kind of the phone book. Hey, give me an address and I'll tell you who lives there.
Gotcha. Now it makes sense.
Yeah. So yeah, and he said that's the key is using this hash map. You can't just pass it to an application and then have it send data directly to the handler. He said no, make sure to have this hash map. So
Okay.
the one thing it didn't mention that I hope I did right is you have to actually tell the hash map how to handle it. So there has to be an actual and that's where this map command comes in. It says, hey map, if I get a command of add, in my case, use the addition handler. If I get one of subtraction, use the subtraction handler. And so that way, when it finally does get put in, when it says, hey, handle this request of add and these two numbers, it knows what to do there. So
Clear. Yeah. Okay, cool. That was pretty good, man.
all right, cool. Yeah, without any question, I'll stop the broadcast, but